Hi guys, we are back again with another NeetCode slash LeetCode grind session. Today we will be again revising the linked list questions that we did yesterday, predominantly the merge case sorted linked list, the hard question. The one that I came up with on the yesterday's video on my own was O of n into k time complexity solution, and the one we saw of NeetCode was O of n log k, which is better. So we'll try to revise that logic. Also do merge two lists together question and reorder list as well. And after that, I'm thinking whether should I do sorting window or should I go to binary search. But I think like if I go to binary search, I'll be in the mindset of binary search, while sliding window I've been doing it, so maybe I'm comfortable there. I don't know. Let's see what we can do. Um, but yeah, so essentially let us try to do merge two sorted lists together question, right? My favorite question, right? And we have basically given two lists, we have to sort them. So the first thing we'll make a dummy node. So before even coding, let's just try to think about this, what we're trying to do. So we have 1, 2, 4, and 1, 3. So first thing we do in these type of questions, we make a list, we make a dummy node, so to speak, right? And we say tail is equal to dummy. Now we would like to compare the two values, right? So for that, also let me just change this to um, FL L2. ठीक है, let's change to L2. So we want to compare those two values. So while they are not null, then only we can compare these two values. So let's say I have a dummy node. So dummy node, and dummy node का भी ये none है, and our tail points over here, right? So in the case, and I'll do few cases, if L1 dot valve is less than L2 dot valve, we will do something. The else case would be, in this case, L dot valve is greater than or equal to L dot to valve. So we'll do something over here. So while L1 dot valve is less than this, what we will do is we will say tail dot next is equal to L1, and L1 is equal to L1 dot next. So we can go to the next element. In this case, because there to be two conditions, either L2 is less or equal to, in both the cases we'll do tail dot next is equal to L2, and L2 is equal to L2 dot next. And by the end of the loop, we will know for sure that at least tail will be pointing, tail next will be pointing to some other to another node. We know that either this condition will be true or this condition. So we can say now tail is equal to tail dot next. Right, so what this has done is now we compare the two values. So let's say over here we compare them, ये equal है. So what we say is we essentially say कि now this is pointing to this, and now tail is over here, so to speak, and now we push this aside. Now we compare the two, and so now tail of this will be pointing to this, and this is our tail now, right? And so now that we have checked this, we will come over here, we will check that. So now tail will be pointing over here, tail will be over here, and that is the case. Now we have to take care of another edge condition. If L1 is not null, that means L1 में still बचा है elements, we can just do tail dot next is equal to L1. If L2, then I can do tail dot next is equal to L2, because अगर कुछ भी बचा है, we know by the end of it either L1 में बचा रहेगा या L2 में, दोनों में नहीं रहेगा, because हम लोग यहाँ पे जो भी shortest है उसको पहले किया जाएगा, and maybe it could be the arrangement of the number. Anyhow, if कुछ बचा है, अगर L1 नहीं है null, so we just do tail dot next is equal to L1, and that will equal to L2. And then what we return is we return dummy dot next, because that will be the start of the linked list, the merged sorted linked list. And if we run this again, it passes. Let's try to submit this code, and wow, it works great. So this is essentially how we merge two sorted linked lists together. This forms the basis of merge k sorted linked list together, right? So let's try to solve that real quick. So now we have linked list, now we have merge k sorted linked list, right? Over here, this is another a weird solution, so to speak, right? But here, okay, this is essentially the most other solution is you do that. But the first solution is we will use this function that we had over here into our advantage. So how will I do that? That's the good question. I'll copy that and I will paste it over here. And yeah, so this function is valid. And now you have to merge k sorted linked list. Now the way I initially did it was very naive. I said merged head is equal to none, right? And I said for head in lists, right? Right. I'll say for head in lists. So all the head, it will pretty much be merged head is equal to merge. Actually, to be honest, a better way of doing this for I in range of length of lists, right? And I'll say if I is equal to 0, we'll do something else, else we'll do something else. So if I is equal to 0, that means it's the first element. We will say, well, merged head is equal to list I, right? Else what I will do is I will do merged head is equal to merge to list, right? And the way to call this, because I'm calling something inside, we'll do self, and then I will give merged head itself and list I, and then I will just return merged head. Let's see if this works. Yeah, so the test cases passes, and this was our naive solution, so to speak. The solution works. So imagine if, like, I'll just imagine we have these containers, so these are our linked lists, and let's say the worst case scenario, the length of each of them is, length of each of them is n, and we have around 1 2 k. So for each n, so we are basically doing this operation, which is again merge two lists. And merge two lists, we are assuming it's n, it's O of n algorithm, so we're doing n into t. So this is n into k of complexity. Not bad, but it's not good enough. How can we improve this? So the way we can improve this is quite interesting. Let's say we have these linked lists. What we can do is, instead of doing it iteratively, like one by one, we can say, okay, like these two, we will merge it into one list. These two will merge it into one list. And then we'll do these two into merge into list. Now, see how we have cut down the number of operations. We do this the first time. So this is our first time we are doing this, and we merge them the second time, and then this is our two time doing this. Why though? Right, this is still n of operation, this is n of operation, but we're doing n two times. What does that 2 represent? Well, what we are doing is we're dividing the entire k, right? We're dividing the k by half, so we are essentially going to get log k. These many times we can divide it before it becomes into one undivisible unit, and each time we're doing it, we are doing an n operation. So this is obviously much smaller than O of n k, right? Like this is the way smaller, and so we can go for this. So how do we actually write the solution is the more interesting part of this question. Right, so how do we write this solution? So in order to write this solution is quite simple. First of all, you have to take care of the certain edge cases, which kind of suck. The number one edge case could be if length of list is equal to 0, or so pretty much it's going to be like 2. If length of list is equal to 0, or list is none, it could be those cases. We will just return none. Like that takes care of some of the edge cases that we don't have to worry about. And the way this works, it's so interesting. I mean, I saw this solution yesterday, and so what we say is, well, okay, we say while length of list is greater than or equal to 2, because if it's greater than or equal to 2, that means you have to merge two things. We'll do something. What we will do is we will say for I in range of 0 to length of list by 2. So we'll jump by 2. What that 2 means over here is, let's say if we have 0 1 2 3, it will start from 1 and then it will jump 2 times, so it won't iterate over 1, right? And that is important because we can say L1 is equal to list I. Now I don't know whether L2 can be out of bounds. We can have like 0 1, so it chooses this, right? Let's see if it's only to be honest, length of list is greater than equal to 2. Yeah, so it could be the case where we have three length, right? This thing chooses this, and then the pointer comes over here, and then it goes out of bound, right? To check. So we have to make that check there, and we can say if I plus 1 is greater than or equal to length of list, right? So it's pretty much out of bounds, so to speak, right? We will say L2 is equal to none, else we will say L2 is equal to list I plus 1, right? That is just our bounds check that we're doing, right? So if I plus 1 is greater than or equal to the length of list, we say L2, and we do that. That is great. And then we come over here and then we say merged list is equal to empty. This is going to store our list as a format, and what this will do is it will just say merge list dot append. What is this thing gonna append? It's gonna append self dot merge to list L1 L2, and it's gonna essentially just merge that, right? After this is done, so what will happen is after this is done, merge list will contain the half element, so we'll say list is equal to merge list. So now this loop will run again until it's done, right? And now we want to return the head of it, so what we'll do is merge list 0, and this will return the head of the sorted thing, which is great. And you see our test case pass, and if we submit this, it runs again. It's much faster than the last time we ran it. So this is so interesting, right? Because initially this is empty, and we run this loop, and by the time this loop comes over here, we have essentially half of the elements in this list, and so we see list is equal to merge list, right? So this things happens iteratively unless this condition is false, and the moment this is false, we just return merge list 0, right? So this is just beautiful solution, to be honest, right? I think this solution is taken care of, to be honest. Like, if what I'm meaning to say is if I do, does this run though? Oh, wait, what? But if length of list is equal to 0, so while this won't run. Ah, okay, so this, so I think the best solution we can do is merge list is equal to this, and okay, I think I'm doing something wrong. Hmm, interesting. I'm doing something wrong. Yeah, I'm doing something clearly wrong by not letting that go. Because this loop shouldn't run anyhow, right? That loop shouldn't run anyhow. It's saying, okay, wait, on this solution it's saying merge list dot. Ah, because it's not clearing it up. Yeah, my bad. Yeah, so essentially what's happening is because it's outside the loop, it's being initialized to that. It's pretty much adding up to it, and we'll never run out of that. My bad, my bad. That was dumb. That was dumb. My bad. That was just dumb of me. Sorry. Yeah, that was dumb. Okay, that's good. We learned something. The reason why this is being done the way it is done. Um, wow, we have celebration animation. But yeah, that's understandable. Yeah, I understand that. Cool. Yeah, so that was our merge k sorted list. O of n log k solution, which was great. We also have reorder list, which is I think great. So the way we find the middlemost element of and linked list is we start with a slow pointer and our fast pointer in these initial positions, and we move our fast pointer by 2 and our slow pointer by 1. The moment our fast pointer points next element is none, or the fast pointer has become none itself, we look at the slow pointer will be pointing to there essentially, right? So the very first step in this, we're gonna find the middle most node, right? So we want to find the middlemost node, so we'll say slow And actually, if you look at the conditionals, the length of the list will be 1. So we can say fast slow and fast is equal to head dot next. Right, if I format this is better enough. Now if fast and fast dot next, obviously because both need to be true, we will say fast is equal to fast dot next, and we will say slow is equal to slow dot next. And the moment this stops, right, the moment slow will be now pointing to the middlemost element, right? Slow will be pointing to the middlemost element right now. So we want to say second is equal to slow dot next, and we now disjoin the list. We'll say none, right? Now reverse the second half of the list. So we want to reverse the second half of the list, and we know how to do this. We can say previous is equal to none, and we can say current is equal to second. And we have been doing this for so long, so I think it's, so we can say while current is not none, what this could be is we'll say current, so we'll say temp is equal to current dot next, right? And we'll say current dot next is equal to previous is equal to current, right? So now we'll say current is equal to temp, right? So we'll say temp is equal to current dot next is equal to our previous is equal to current, and current is equal to temp, right? And now we know the same filter, so we'll say this as our previous element. Great. Now we will merge the two linked lists, right? So we'll say first, we will say, so essentially what we can say is we can say first is first, second is equal to head previous, so because our head still remains where it is. Now we know either they both will be equal or second will be a little bit less by 1. So we can say we'll do, because second is the limiting element, right? So we'll say temp, first of all we'll keep them temp2 is equal to first dot next, and this is equal to second dot next, right? And now I'll say first dot next is equal to our second, so right, and second dot next is equal to temp1, right? And then I will say first, yeah, so okay, and then I'll say first is equal to tmp1 and second is equal to tmp2, and let's run this. I think this is right. Okay, I got a mistake and I'm happy for it. Let's see what the issue is. So we have first dot next, that's the issue. Okay, so this is reorder list obviously. Okay, so first of all, find the middlemost element, so slow and fast. So this is the current if fast dot next, so fast is equal to fast dot next, slow is equal to slow dot next. Yeah, so either fast becomes null or fast dot next becomes null. The either way we stop. Then we say second is equal to slow dot next is none. Previous is equal to none, current is equal to second. So while current is not none, temp is equal to current dot next is equal to previous is equal to current, and yeah, that's right. Current is equal to temp. That is true though. Temp1, temp2, first dot next, second dot next. First dot next is equal to second dot next is equal to tmp1. First is equal to tmp1, second is equal to tmp2. I mean, I could write some check like saying if head is none, then return, right? I think something like that. It's still issue आ रहा है. What? कुछ तो गलती कर रहा हूँ मैं. So that is the reason why this is happening. Relax, Ujay. So initially find the middlemost element. Nothing is wrong over here, and it's given key length of list will be at most this. Then um hmm. मैं गलती कर दिया. While this has to be while, right? We have to keep on iterating, right? Sorry, my bad. So that वही गलती हो गया होगा. And if we submit this code, does it work? Yes, it works. So this is how exactly it works, right? Yeah, that's how it works. Great, cool, cool. Um, let's reorder. Yeah, I mean, and linked list cycle detection is again. So again over here, what we'll do is we'll have both of them start at slow and first initially, and then on the first iteration, I mean, to be honest, you could do something like this on the first iteration. You could have slow come over here and fast come over here, but you want to make sure the list is valid, so to speak, for that to happen, right? So we say this is our actual. So we'll have slow, and so initially we'll have slow and we'll have fast. So fast will again move by 2 and slow will 1. So 1, 2, and this by 1. And so this moves over here and then 1, 2, and this comes again. Again, this will be an O of n time complexity. Great. I'm thinking of doing sliding window. Right, my heart's temptations are saying me to do sliding window, so I think we'll do sliding window. So we did best time to buy and sell stock, which was great. We were able to like do it by ourselves. Longest substring without repeating characters was also done by us. Longest repeating character replacement. So I don't know about this, but let's see. Let's see what we can do. What do we need to learn? Okay, let's see, chat, if we can solve this. Let's start. I think 25 minutes is fine. Timer. Let's go. So let's start. Okay, you are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. So at most k times meaning less than or equal to k. Okay? Pretty much that's what it meant. At most k times. Return the length of the longest substring containing the same letter you can get after performing the above. Okay, I didn't understand this at all. So let's look at the example. So we have A, B, A, B, and K is equal to 2. That means we can change any character of the string to other uppercase character maximum 2 times. So the output is 4. What does that mean? Replace the 2 A's with the 2 B's or vice versa. Okay, I understand what that means. Return the length of the longest substring containing the same letter you can get after performing the above operations. K is equal to 1, 4. Replace the 1A in the middle with B and form the substring BBB has the longest repeating characters, which is 4. There may exist other ways to achieve this answer too. Wait a minute, chat. So, as far as I understand what this question is saying, right, let's try to conceptualize. This question is saying we have given a string, right? Let's say over here we have a string. Right, and we can, so we have this string which is ABA. Now our job is to find the longest repeating character replacement. That is, given that k is equal to 2, we can replace change, so we can choose any character of the string and change it to any other uppercase English character. So in order to get the longest string, well, I can clearly say I can do either A, change this to that, A and this, or I could do change that to this, B, B. So the answer will be 4, right? And again over here as well, this is another example where we have this. What is the longest repeating character substring? Given that we can replace one with another uppercase character. So if I look at this, A, 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 B. Okay, well that's, I can change this. And if I change this, I can get a 4. Great. If I change this, if I change this, I'll get 2 A's. So if I start from here, if I say A, B, well, I can change it once. So I can change this to an A. That means I can do A, right? Like if I'm over here, I can do A, and I can change it once, and then I can do A. So this gives me 4. But then I stop there. right? So I can't really give any more because the next element is B and I don't have that credentials to do that. Hmm. So now what do I do? To be honest, because I have checked till here, now I want to check over here. So now I'm going to start from that element. And what I mean by that element is the last element there. I can say, well, I can say B. I can change it to B and I can say BP. Okay, well, this gives me 4, right? Um, and so I calculated essentially this window. And where do I want to start the substring then from? Okay, so I stop over here. Now I can't proceed further to unless there's more A's over here, but I can't really do anything about it, right? Because A, B, A, अगर उसके बाद A नहीं है, so I can't really like this is the end of it. Like I have to calculate this because इसके बाद नहीं है, because either this इसके बाद A नहीं है और हमारे पास K भी नहीं है. This is the maximum we can form. So we start from this and we do this. Well, this is the maximum we can do, right? I'm just confused. How do we solve this? So we start from here. Um, yeah, ये यहाँ तक आ गया. And so I've calculated this substring. Now I can say, okay, well, I'm gonna do it from here. Well, that doesn't really matter because this यहाँ पे तो रुकेगा. Because यहाँ तक we have used 1b. That's no use of calculating any further. So the way to calculate this further is to start from b itself and then calculate this. And this is the limitation, right? I mean, like this is the limitation, so to speak. Like यहाँ तक इसका limitation यहाँ तक है, right? So then I can start from here, right, so to speak. I can start from there and I can say, well, if this is the case, I can do P, 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 and I can do that. So this gives me 3. I mean, I get it. Like, I get it. Like, let's say if this example as well, I think I am forming an intuition of how to solve this. Let's say I start from X. So I can, if it's not, then I can convert it into X. So that means I can do something like X, 2, 2. And now I don't have anything. So this gives me 4 because I've reached the end, right? And then this is the end of it. Like this, I've reached pretty much the end. And there's there's no use of calculating this. Why there's no use? Um, It's S, right? So for C in S, right? For C in S, I think much better is if we do something like I is equal to while I is less than length of. So I don't want to write any code. I just want to see how I do this. So I start from A and I keep going until I see something that is not A, right? So I said, okay, but we'll have it till A. And how many characters are we exposed to? Oh man, is this gonna consist of like CK, BS type scheduler discussions? This feels hard. Carrier. This could be very tough, guys. S consists of only uppercase letters. That's kind of shit. That could lead to a lot of issues, but I won't think about it right now. So okay, while I is less than S, right? And we wanna continue this loop, right? If so, we wanna start this loop. If so, we start this loop and we say, okay, we wanna essentially we're at A at the moment, and the reason why we wanna go ahead is because you know, right? So this is equal, but how do we know? Um, my bad. Yeah, okay, my time is चला जाएगा. Anyhow, so I start from here. I start at A. I want to go ahead. So I think the only way we can do this is remove -1 and we can say while si plus 1 is equal to si, right? So while this is equal, so we continue going ahead and right, we say, okay, well, that's kind of so, right. Right, so we are continuing over here. Come over here. Ah, man, this is not cool. This is not cool. This is not cool because this is essentially just gonna be quite shitty behavior. How would I solve this? How would I solve this? We have A, B, A, B, B, A. So I start from A. I'm like, okay, well, that is A. Great. I go to the next element. Well, this is also A. Great. So we just keep on adding to this. Um, ये run होएगा ही नहीं, right? This won't run. This will run up until the point, right? This will run only up until the point where जहाँ यहाँ पे हुआ, and this will stop, right? Essentially, this will essentially just stop, and now we'll say, okay, that means that is not the case. Ah, man. Um, I think I'm not conceptualizing this properly. Like, if I conceptualize this properly, let's take a very simple example, I guess. A, B, A. We are at A, right? And I see B. let's say we start at a. So we'll have, let's say, a substring value. So we have a. So we have a, right? So if s dot a not in substring, if it's in the substring, right? So the first one will, obviously we won't check this for the first one. We'll say if I is greater than equal to 1 and, right, if it's equal and it's si is in the substring, then only we'll say substring is equal to plus, right? So actually one better way of doing this is, and this is very bad code, but this is the first element, so it won't be in the substring, so we'll just um, this is very bad, but anyhow, right? So we have a substring a, right? If s dot a not in substring, that means this is our b class, right? This is our first non, right? Else if it's in the substring, right, that's great because we want that, right? So we just do plus equal si. Now if it's not in the substring, right, if it's not in the, so we do a, right, a is not, a is equal to I, we do this, we go b. Well, b is not in the substring, right? B is not in our substring at the moment. So what we can do is we can say kk is equal to k, and we can say kk is equal to k minus 1. So we use one of our k's and we say substring plus equal whatever it's in the last, right? So if that's not the case, we do a, and then we move ahead to a. If it's equal, that's great, then this is a, and then we come to b. And the reason why we're able to do this, if, man, this is not cool, like if we're doing multiple if statements, it's not at all cool. I think the best way to do this, right, if I is greater than equal to 1 and then we want to do something about it, right? This is the one that we want to this is what we want to know about. Else, come on, come on, man. This guy, is this, don't anger me right now. Okay, I'm going to do this bad, right? Okay, I'm just going to do this the bad way, I guess. Okay, so first element is inside, right? So this is our first element is inside. Say if si not in substring, right? If this is not in the substring, what we will do, else, I mean, if it's in, this element is in the substring, then we'll just do substring, right? Let's say I is not. So if kk is greater than 0, that means we have not exhausted our chance, then we'll do something, else we will not do something, right? If it's equal to 0, we will say, well, okay, fine, this means we can say something like substring is equal to substring minus 1, and we can say kk is equal to minus 1. Now if so, okay, so this might, we might get close now, chat, we might get close. अभी substring का length ये है, right? Great. um, right. So now I 0 1 2 3 अभी आई आया, लेंथ ऑफ सबस्ट्रिंग 0 है तो हम लोग अभी ए डाल दिए. नाउ बी, क्या बी सबस्ट्रिंग में है? नहीं है बी. तो वील से वाइल क्या के ग्रेटर देन इक्वल टू 0 है, राइट? के इज ग्रेटर देन इक्वल 0, विच से सबस्ट्रिंग इज इक्वल टू व्हाटएवर ए में लास्ट में है उसमें हम लोग ऐड कर देंगे. सो अभी 2 आ गया एंड इसे के माइनस 1. ग्रेट. क्या वो है सबस्ट्रिंग में? इफ के इज, if it's equal to 0 essentially. Essentially if this is greater than or equal to 1, मतलब अभी भी है इसमें, right? So right, a है, that is great, so we do else, we come to b. well अभी भी ये अभी आपका अभी 3 हो गया एंड ये अब 2 हो गया. well अभी भी मौका हम लोग के पास, राइट? 3 से अब हम लोग काट के एक और 2 आ सकता है, तो ए अब 4 आ गया हम लोग के पास, right? So what we can do is lrcp max is equal to lrcp max of substring, right? Okay, so this works. If I run this, वाह क्रेजी, मजा आ गया. else uh, आई ये क्या हो रहा है? हाँ, का क्या इसमें इसमें दिया क्या है इसने? 2 दिया है. ओके. Oh, 26, 25 seconds. That's great. इसमें आवाज क्यों नहीं आ रहा है इसका? Oh, crazy. Some lead code questions, make you sad, some make you happy. It's always a challenge to be positive. It's sometimes a challenge, to be positive sometimes. I don't need this, to be honest. What we can do is we can say lrcp I slash t is equal 0 0 0. Right, pretty much that's um, I mean, it passes these test cases. First of all, yeah, print मत करो यार. Let's remove the print statements. Actually, I don't think it will pass the other tests. To be very honest with you, um, I don't think it will pass the other tests. I'm happy it passed the test case, but other than that, I don't. Yeah, this will one test case will either fail this shit. Yeah, time limit exceeded. Why did it? ये रन ही नहीं कर रहा है क्या? Okay, this is running. हाँ मैं समझ गया. Okay, now this is tracing up. Okay, now we come to B. B नहीं है. क्या K equal to नहीं है? नहीं है. तो मतलब क्योंकि हम लोग उसको कट नहीं सकते, हम लोग बोल सकते हैं एल आर सी पी इज इक्वल टू मैक्स ऑफ एल आर सी पी लेंथ ऑफ सबस्ट्रिंग, and length of substring is a till now. Then what do? We say I is equal, and we also ensure key. First of all, one more thing. If I do interesting. क्योंकि वो है ही नहीं उससे बड़ा, right? Hmm. This could be it. So we will either ways just do k is equal to I. In essence, I'll do t is equal to I because this might be it. Does this solve that thing? Could solve it, right? right? I think what's happening is we're gonna say this might be it. So I'll say t is equal to I, right? This might be it. And this is wrong though. I can tell you this is wrong already. Um, yeah, so we're pretty much reinstating it. Um, Pretty much reinstating the fact that you don't think we can do it. But this is wrong. I just don't know what on my mind. I know it's wrong. Yeah. Um, what? Also, one more thing, we're doing something like if I is equal to 0 as well. Because that's the first element. The first element wouldn't really. Ah, this is wrong. 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 Yep, this is wrong. I just figured that. That's wrong. That's wrong. You can't do like that. You can't do like that. You can't do like that. That would be wrong. That would be wrong. Anyhow, P आ गया. So many if conditionals. Chat, I might have to give up. Yeah, I'm not I'm getting nowhere with this, to be honest. Like, I'm getting nowhere. I'm so dumb. I'm getting nowhere with this. I'm actually kind of sad. I thought I would be able to solve this, but yeah, it seems like I'm not the goat, chat. Not the goat. I don't know how to solve this. I'm so confused. 20 minutes long video.
Hey everyone, welcome back, and let's get some more NeetCode today. So today we're going to solve longest repeating character replacement. And so this is another problem from that blind 75 list. So we are going to be one step closer to completing the entire list. The link will be in the description to the spreadsheet if you do want to take a look. And hello to the 6 people that are currently viewing the spreadsheet.
Um, yeah, I would like to do this question again.
Right now, you're going to be in the next video. But okay, so let's get into viewing the spreadsheet right now. You're going to be in the next video. But okay, so let's get into this problem because it's another pretty fundamental problem that's really good to understand. So we're given a string s and a single integer k. And so basically they tell us that we can choose any of the characters in the string and change it to any other uppercase English character. So in this problem,
I mean, I feel like I could solve this, yeah, to be honest. Like, man, let's look at the discussion page to make me feel good about myself.
input string is going to be limited to uppercase English characters, and we know that there's 26 uppercase English characters from capital A to capital Z. And so basically we can perform a replacement on any of the characters at most k times. So we're allowed to replace k different characters in the string to any other character we want. And what we want to do is return the length of the longest substring containing the exact same character we can get after performing at most k different replacements. So we just want to return that length. We don't actually have to make those replacements in the input string. So in this case, when we take a look at the input string, we have A, B, and we're allowed to replace two of the characters. So what's the longest substring we could get with the exact same character? Well, we could replace one of the B's. We could basically replace both of the B's with a capital A, and then we get 4 A's in a row, which would give us an output of 4. And we could technically also do the opposite. We could replace the A's with capital B's, and that would give us the exact same result, a length of 4. So I'm going to show you how you can solve this problem in big O of n time, and technically it's going to be big O of 26 multiplied by n, which we know is also reduces to big O of n, but there's actually technically an easier way to do it, or at least a more simple way to do it, which is just going to be a flat big O of n. We don't even need this 26 constant. But this way is actually pretty tricky to get to, so I'll be going over a little bit of it, but this is kind of the main way that you'd want to solve this problem. So let's say we're given an input string like this, and we're given a k value. Now the most brute force way would just be check every single substring, right? And if we were checking every single substring in the entire input array, we know there's n squared substrings, so that wouldn't be the most efficient way to do it. But even if we were doing it like that, what exactly are we looking for? If we're looking at a particular substring, how do we know if this substring is valid? Because remember, at the end of the day, we want to maximize the result, right? The result is going to be the longest substring that contains a single character, and we can make 2 replacements. So let's look at this substring alone. How do we know if it's valid? Well, which character are we going to replace? Are we going to want to replace the B's in order to make it all be to match A, or would we want to replace the A in order to match it with the rest of the B's? Of course, we're going to replace the character that occurs less frequently, right? Because the number of replacements we have is limited, so we would want to replace the characters that are less frequent. So in other words, we want all characters in a particular window to match the most common character in that window. So what we're going to be doing is we are going to have a hash map or a array, which is going to take every single character. In this case, we only have characters A and B, and we're going to count the number of occurrences of each character. So for example, if we were looking at this substring, we see that there's 3 B's and we have a single A. So how do we know if this window is valid? What we're going to do is we're going to take the length of the window, which is going to be 4, right? We're going to take the length of the window, right, which we know in this case is 4, and we're going to take the length or the count of the most frequent character. In this case, we know that that's B, and the count of it happens to be 3, so we're going to take 4 minus 3, and from that, we're going to get a 1. Now, what does this value 1 tell us? It tells us the number of characters in our window right now that
Other than
we
B.
need to replace in order to make it match the most frequent character B, right? We have a B here. We want everything to match a B. In this case, we only have an A, right? But it could be possible, like, who knows, maybe that we would have a C over here, right? Or an X over here. And it doesn't really matter what the characters are. We just know that B is the most frequent character in the window, and the other characters that are not B, A and Z, for example, are the characters we want to replace. So we can calculate the number of characters we want to replace just like this. And so we want to replace 1 character. How do we know if we have enough replacements to do 1 character? Well, of course, that's our input parameter k, right? So what we're confirming here is that this value is less than or equal to k. As long as this condition is true, that means our current window is valid. That means we have enough replacements to make those replacements in our current window. So this is the main condition that we're going to be checking. The other question is, how are we going to know which character is the most frequent? Well, the brute force way is going to be taking a look at our map of counts, and we know that the max size of this could possibly be 26 because we'd only have 26 different characters. So finding the max character is going to be big O of 26, so that's a little bit more inefficient than we would like, but it's technically still linear time. Like, the overall algorithm is we're going to equation, we're going to have to add a sliding window technique. So basically what we're going to do is we're going to take our window, start at the beginning, expand it as much as we can, as long as the condition that we mentioned is valid. If the condition is not valid, then we're going to take our left pointer and then shift it as well until the string becomes valid once again. So we're going to have a left and right pointer. So initially left is going to be at the beginning and right is also going to be at the beginning. And also the counts of A and B are initially...
Wait a minute, Chad, wait a minute.
Now we're going to look at the first character, right? That's where our right pointer happens to be. We're going to look at it. We're going to say, okay, we have a single A, right? We're going to take our count, of A and set it to 1 now. So is this window valid? As in, can this window be the exact same character within 2 replacements? Of course it can, right? That's kind of the trivial case, but we would still calculate it. And the way we would calculate it is get the size of our window. Right now we can see the size of our window. In this case, 1 subtracted by the count of that valid, that's correct, can be set to either of these, right? And the count of the frequent characters we would have to do, and looking at -1 equals 0, that makes sense, right? It's the number of who is the length of the longest window. Get to update our result, ensure that so our window is currently valid. I guess I did forget to update our result. So since this window is valid, the length of the window is going to be set to the result, right? So right now the result is 2. 2 is the length.
ओके सो बेसिकली विंडो में जो भी मैक्सिमम रिपीटिंग कैरेक्टर है माइनस द लेंथ ऑफ द स्लाइडिंग विंडो, अगर वो के से कम है, इक्वल है, देन ओनली दैट इज़ वैलिड. दैट मीन्स वी कैन रिप्लेस इट एंड गेट द लॉन्गेस्ट सबस्ट्रिंग. अगर वो के से बड़ा है तो कोई फ़ायदा नहीं है, क्योंकि आपके पास कोई एक डिसकंटिन्यूअस ब्लॉक रहेगा. दैट वाई वी डोंट कंसीडर वैलिड.
Of the longest window that we can get. So that's our result for now. So now let's continue. Next, we're going to shift our right pointer to the third character. So now we get another A. So we're going to take the count of A and increment it all the way to 2. And we're basically going to repeat our algorithm. So once again, we're going to get the length of the window. So of course it is. So go to the 2 now is equal to K. Once again, 2. And we found a 3. So the length of the window now is 5. Is this 2? Our window, we have 3 B's, so that means we're going to be replacing the A's, so we're going to need to make 2 to get to the case that I mentioned earlier, window problem. So pointer and then slide it to the right, which is why this is a sliding window problem. So now we reached an A, so we're going to take the count of A and set it to 3. So now we have A count 3 and B count 3. So let's take the size of our window, 6, subtract from it the count of the most frequent character. It's going to be either of these, so 6 minus 3 means we need to make 3 replacements. Is that less than or equal to K? K is 2, so we exceeded K, right? We exceeded the number of replacements we're allowed to make. If we wanted this window to be valid, we have to replace 3 characters in it, but we're not allowed to do that. So what we have to do is shrink the size of our window until we are valid. So we're going to take our left pointer and shift it to the right. So now the left pointer is going to be over here. It's going to be at the B. So since we removed this A from our window, we have now the count of A. That's going to be once again valid. Window we can make is either this window or the window that we had earlier with these first 5 characters. But yeah, and so at this point we would stop our algorithm because we did find a window of 5 that is valid, and our right pointer cannot be shifted anymore. So this is the general algorithm. So it's a basic sliding, it's a fundamental sliding window problem with this particular condition being important. But there's actually one way you can do it without having to look through the entire hash map every time you want to find the most frequent character that occurs. And it's kind of tricky to arrive at this solution, but it's pretty easy to implement once you can figure it out. I'll explain the algorithm at a high level. I don't want to waste too much time on it, but basically we're going to be having another variable, and it's going to be called max frequency, basically the count of the most frequent character at any given time. So basically, for example, if we had A as a count of 3 and B is count 2, we'd say, okay, the count of the most frequent character occurs 3 times, so max F is going to be 3. And so anytime, if we got a B, let's say we incremented our B all the way up to 4, then we'd want to update our max frequency to 4, right? So we'd always want this to be the most frequent character. Now, the one problem is if we're trying to maintain the count of the most frequent character, what happens when we take our left pointer, for example, right, and then shift it, right? When we do that, we're basically removing a character, and therefore we're going to have to update our count map, right? We are going to do that. And if that does happen, right, let's say we took B and then from 4, we decremented it all the way down to 2, for example. Then we'd have to rescan this entire map and then find, okay, what's the new most frequent character, right? So we'd have to take our max frequency and from 4 downgrade it all the way to a 3, for example. So then we'd have to set it to a 3, and that would basically defeat the purpose.
Yeah,
We'd still have to do that
26. Yeah, yeah,
calculation to
pretty much.
get through this, but it's technically true that you don't have to decrement this max frequency. But the main idea is this: the result is only going to be maximized as we find a new max frequency, right? Because remember what we were doing. We were taking the length of the window subtracted by the max frequency, right? Whatever the most occurring character was, and we wanted to minimize this, right? So basically we want the length to be maximized because that's what our result is going to be set to. So therefore we also want the max frequency to be maximized because we want to ensure that this is less than or equal to k, and k is going to be a constant. So for example, let's say I had a max frequency of 4, but let's say now the new max frequency got downgraded to a 3. I'm still going to leave this as a 4 because it's not going to change our result. Because for example, if I had a 6 minus 4, that was less than or equal to k, which is 2 in our example. And if I leave this as a 4, I'm basically overestimating what the max frequency is, but we know at least at one given point in time it was a 4, so therefore we were able to take the length 6 and then set it equal to our result. And now, so let's say our result is now 6. If we're ever going to increase the result from 6 to another number, like for example 7, we would require our max frequency to increase. If it stays the same,
Okay, I understand that. I'll just
we're just going to return a default value of 0. That's a more optimized solution. Okay, so now let's jump into the code, and the code is actually a lot easier than the visual example that I gave, a lot shorter for sure. So we're going to have a hash map to count the occurrences of each character, and we're also going to have a result, which is going to tell us the longest our right count, k replacements, and we're going to have a left pointer, which is going to be at 0, and then our right pointer is going to go through every single position in the entire string S. So what we're going to do is for the character at position R, we're going to increment the count of it. We're going to take 1 plus whatever the count currently was, count.get this character. And if the character doesn't exist in our hash map, we're just going to return a default value of 0. That's what this function is doing. And so before, what we're going to obviously do is update our result, right? And we want to set the result equal to the max that it...
give it a minute. So we have something like results is equal to 0, and we say count is a hash map, and we have L is equal to 0. For our in the input method. Okay, and we say yeah, so whatever the count is just incremented by 1 if it doesn't. Okay.
It's ever been, and set it basically equal to the size of the window. We can get the size of the window, so we're going to take the max of result, and the
Or minus
size of the window can be gotten with right minus left plus 1. And before we do this, before we update the result, we want to make sure that the current window is valid. So what I'm going to do is basically say while, and I don't think you would actually need a while here. You could just do if, but I'm just going to do while just because. So while the window is not valid, and we would know that by taking the length of the window, which we have down here. So I'm just going to copy and paste that. The length of the window subtracted by the count of the most frequent character, which can be gotten with max of count dot values, right? We're basically going through the hash string, which could be size 26, and just getting the max value from it. So this is the number of replacements that we have to do, and if the number of replacements was greater than the number...
Okay, I understand what you're trying to say. So, um,
number of replacement count of the character k replacements was greater than the number of replacements that's allowed, which is left pointer. But before we increment the left pointer, we'd want to take the count of the character at the left position and then decrement it by 1. And that is the entire algorithm. After all of that is done, after we've gone through the entire string, then we can just simply return our result. And as you can see, this is pretty efficient. It's linear time. It's about as efficient as you would need, I think, but I'm going to make that slight optimization that I showed you. I'm going to maintain the max frequency.
what's the issue over here? एग्जिस्ट ही नहीं करता. Again, this is some bug in this shit, bro.
In a single variable so that we won't have to, we can use it in this loop execution, right? So we can replace this and just use number of occurrences of each character. So let's say we're given an input string like this and we're given a k value. Now the most brute force way would just be check every single substring, right? And if we were checking every single substring in the entire input array, we know there's n squared substrings, so that wouldn't be the most efficient way to do it. But even if we were doing it like that, what exactly are we looking for? If we're looking at a particular substring, how do we know if this substring is valid? Because remember, at the end of the day, we want to maximize the result, right? The result is going to be the longest substring that contains a single character, and we can make 2 replacements. So let's look at this substring alone. How do we know if it's valid? Well, which character are we going to replace? Are we going to want to replace the B's in order to make it all be to match A, or would we want to replace the A in order to match it with the rest of the B's? Of course, we're going to replace the character that occurs less frequently, right? Because the number of replacements we have is limited, so we would want to replace the characters that are less frequent. So in other words, we want all characters in a particular window to match the most common character in that window. So what we're going to be doing is we are going to have a hash map or a array, which is going to take every single character. In this case, we only have characters A and B, and we're going to count the number of occurrences of each character. So for example, if we were looking at this substring, we see that there's 3 B's and we have a single A. So how do we know if this window is valid? What we're going to do is we're going to take the length of the window, which is going to be 4, right? We're going to take the length of the window, right, which we know in this case is 4, and we're going to take the length or the count of the most frequent character. In this case, we know that that's B, and the count of it happens to be 3, so we're going to take 4 minus 3, and from that, we're going to get 1. Now, what does value 1 tell us? It tells us the number of characters in our window right now that we need to replace in order to make it match the most frequent character B, right? We have a B here. We want everything to match a B. That's a little bit attracted by the count of the most frequent character. In this case, we know the most frequent character is A. 1 minus 1. Is that greater? Is that less than K? We know K is 2, so of course this is equal 0. 0 is less than equal to 2, which is K, right? So of course this window is valid. That's kind of a trivial case. Next, we're going to shift our right pointer to the next character, right? So now we have a B, so we're going to increment the count of B in our map. So B is now going to be set to 1. In this case, the length of our window is 2. The most frequent character is either of these, right? And the count of that way to 2. And of course, it's still true because when you look at our window, we have 3 B's. Removed this A from our window, we have to decorate without having to look through, for example. Then we have to
Okay, chat. Okay. Okay, I'm getting it. I'm getting it. Getting it, chat. I'm getting it. Interesting question, so to speak. Like, opened my mind. Um. So I guess that will be it for today's LeetCode slash NeetCode session. I'll see you guys later. And yeah, thank you so much for joining in. That was a bit of a shocking LeetCode session, but we were able to solve, not able to solve, but understand thing. I think tomorrow we'll revise this again. Bye bye.